Emission Systems Test 3. This is from the Fuel and Emissions Control Systems textbooks, chapters 13 and 14. And we're talking about temperature and throttle position sensors. The sensor that most determines fuel delivery when a fuel-injected engine is first started is the what?
Which one is it?
That's Emission Systems Test 3. Give that to Curtis. He didn't.
Which one? Who's 3?
Read it over there. See? Yeah, I think Curtis is number 2. There you go. All right. All right, there you go. Everybody's got theirs now. Everybody's got it. Okay, that's good. So, once again, what most term is fuel delivery when fuel injected engine is first started? The sensor is going to be, that's going to be A. That's the engine coolant temperature sensor. One time we had a Toyota Camry that was OBD1 that came in here, and sometimes it would start and sometimes it wouldn't. It would spin and spin and spin and spin sometimes. So I hooked an oscilloscope up to the injectors and to some other sensors on the engine and was sniffing around in there while we were trying to start it. I noticed when it failed to start that the injector pulse was really, really wide. And on a scope, the injector pulse looks like this. This being 12 volts. It goes along here. And whenever you're actually measuring the side of the injector where the signal is sent to the engine controller to open the injector, you're going to see it go to 0. This is 0 volts. And then the length of time the injector is open is going to be represented by this horizontal line. And when the injector snaps shut and that magnetic field that's in those windings collapses, you're going to get a spike of about 50 volts. It's going to go way up here. And then it's going to go out like that. So if you see something that looks like that, that's typically a solenoid that's being operated by the computer. And that little spike right there, the computer's got some, some electronics in it to protect it from that 50 volt spike. But if you got your scope set so that it's only got even a 20 volt range, you're going to chop off the top of that little spike. But this pulse on that Toyota I'm talking about was really wide when it wasn't starting. And what I found out was, when I hooked the oscilloscope up to and I've got pictures of this somewhere, on the engine coolant temperature sensor ought to be reading like this, right? But it was actually doing this. It was ragged and going up all over the place. And so the engine coolant temperature sensor was using that voltage from the sensor, and it thought that the temperature was swinging. So the engine coolant temperature sensor is actually something the computer is trying to, on the older ones, before they started substituting values for a failed sensor. But this was in range. It was an in-range failure, and it was raggedly moving around, and it was causing the injector pulse to get so wide that it was too much gas. It was like having to choke stuck completely shut or something, or the injector pulse width was like nearly 10 milliseconds, and it should have been down, below 5 or whatever. One way or another, that engine coolant sensor was keeping that car from starting, and it was an easy fix. Once we found out what it was, we just popped a sensor on it, and it fired up, and it's been driving it ever since. What happens to the What happens to the voltage measured at the ECT sensor when the thermostat opens? Ding, ding.
Decreases.
You need a lifeline? What?
C.
It increases slightly. Now, what do we see? We've seen, how we like to take our Ease wireless vehicle interface and we throw those big yellow numbers up on the screen that represent the engine coolant temperature when we've replaced the radiator or put a thermostat in one, or when we've drained the coolant system. And we're filling it back up. We're going to start it up. We're going to make sure that it's completely full of coolant by letting the thermostat open. We're going to watch the fan kick off and on about 4 times if it has a fan. And we're going to make doggone sure that we didn't just pour water in there like pouring it in a bucket and then drive the thing out of here and then it overheats somewhere down the road. So if you let the thermostat open, the top radiator hose is hot. And incidentally, y'all might not know it, but I've got a forward-looking infrared camera in there that I can actually shoot the radiator hose with. And you can actually see that thing get hot. But what your coolant sensor will do is you're going to see, if you draw it on a graph, like this right here, let's say that you're looking at temperatures. We're going to go up in 50-degree increments like that. We're going to go 50, 100, 150, 200, 250. That'll give us the range we need. And we draw these lines on out like that. What you're going to see over a period of time is you're going to see the coolant. Let's say that it's cool like it is out there today, and you're watching that, and it's going to go up very, very slowly. Now, I hadn't put any time down here, so let's just say that each one of these is like 5 minutes or something like that. It's going to go up. It's going to go up, 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 up. You're going to see it go up, and then you're going to see it go back down. And it's going to level off, and it's going to go up, and it's going to go back down. That's what you're going to see it. Every time a thermostat opens, you're going to see that coolant do that. So if you watch those numbers and you see them hit about maybe 202 or something like that, and then drop back down to about 185 and then go back up, you know the thermostat's working. You can watch the scan tool screen and tell when the thermostat's working. All right, you got me? Now there's another thing. This is, if you're thinking about, later I'm going to be talking about voltage on sensors that actually change gears, like on some of the GM cars and some of the other ones. You'll actually see a sensor that will, the voltage will actually go down, and then it'll jump up and it'll start going down again. It's like it shifts gears for resolution purposes, you know, that's another thing. But this is basically what you're going to be looking at when the thermostat opens. Two technicians are, and this is what we're getting ready to talk about in this next question. Two technicians are discussing a stepped ECT circuit. Technician A says the sensor used for a stepped circuit is different than the one used in a non-stepped circuit. That guy's wrong. Technician B says a stepped ECT circuit uses different internal resistance inside the PCM. Which technician is correct? All right, now the voltage at your sensor, as the temperature goes up, what's the voltage at your sensor doing? You know, the voltage of the sensor starts out high and goes low. As the temperature goes up, the voltage goes down because it's a positive, it is a negative temperature coefficient sensor. Okay, so if you drew a graph and superimposed it over this, you know, like if you could just click and put voltage here, you would see it, the voltage being high would start up and it would go down. As it goes down, the temperature goes up. It would be at a transverse of this. However, on the one that, like in that Oldsmobile we've got, if I took a potentiometer that was like a 50,000 ohm potentiometer and I hooked it up to the engine coolant sensor and I started dialing that voltage down, the scan tool would continue to indicate a hotter and hotter engine. All right, but you would see, if you were monitoring the voltage, you would see that voltage go down to a certain place, and then it would jump up. It would go down to about 0.6 of a volt, or maybe a little below that. I don't remember what the threshold is. And then it would jump way up to about 1.4, and then it would start going down again. And that's basically, if you imagine, it can't really, when it gets down to like at 0.6 of a volt, it's basically wanting to look a little closer. You know how I was grousing the other day about how some of our scan tools, when you're looking at mass airflow, are looking at pounds per minute? And that is a very coarse reading. Like if I'm looking at pounds per minute, yeah, it goes up and down, but let's have a look at grams per second, because that's a whole lot tighter resolution thing. And it doesn't take but a little tiny bit for the mass airflow to be off. When you and I were looking yesterday at that mass airflow sensor, we were looking at pounds per minute, and it was hard to tell what was going on. Even though the mass airflow sensor was the problem, you couldn't hardly pick it up on the scan tool we were using because it wants to read pounds per minute. And I need to hack around in there and see if I can change it to grams per second somewhere. I may be a dummy for not knowing how to do that on that particular tool. One way or another, the stepped circuit, technician B says the stepped DCT circuit uses different internal resistance inside the PCM. That is correct. That's the correct answer. I've got a slide somewhere that shows you that, but that's not anything you're going to use fixing a car. You know what I mean? You don't need to know how the thing's wired up. You just need to make sure that you know what you're looking at when you see that thing change. When testing an ECT sensor on a vehicle, a digital multimeter can be used and the signal wire tested with the connector attached with the ignition on, engine off. What settings should the technician use to test the sensor? Anybody know? DC volts. Now you're not, now Brian, that wouldn't be wrong if you were measuring the sensor with the wires unplugged, because you're reading ohms there. But basically you're wanting to see what the computer sees. Now, eons ago, when I was working at the Ford dealer, the H manual, which is what we call the book that you would use to check all these sensors and all this, the codes and everything, they wanted us to unplug the sensor and check the ohms of the sensor in the book. And I thought, that's the stupidest fool thing I've ever seen. I said, why don't we just back probe the sensor while it's running, see what the voltage is on a good car, went from a cold start all the way up to the thermostat opening, and I'll just remember that. And then whenever I'm checking one, I'll know if it's right or not. Just if you look at a good car, you'll know what it is. All right, so basically, digital multimeter is going to be used with DC volts. I started writing little best ideas contest stuff and sending them into the Ford's dealer, you know, as Service Life magazine. What was the name of that? I think it was Service Life or something. Anyway, we'd send them in best ideas, and I would tell them I was reading voltages at the sensors, and that's how I would tell them if a sensor was bad or good. And the next year, they started putting voltage thresholds in their service engineering. I don't know if I had anything to do with it or not, but that's a smart way to do it, you know. When testing an ECT sensor on a vehicle, you're going to put it on DC volts. When testing an ECT sensor with a connector disconnected, what should you put it on? Brian? What did you say earlier?
Ohms.
Ohms. You're going to check it on ohms, and that's resistance. And it's going to be a lot of ohms. You're going to put it on your probably your 200,000 ohm scale, you know, because it's got a lot of resistance. When checking ECT sensor with a scan tool, what temperature should be displayed if the connector is removed from the sensor with the key on, engine off? D, 40 degrees. Now, have you noticed that 40 degrees Fahrenheit and 40 degrees Celsius are the same? That's where those two scales cross, is at 40 below zero. When I say 40 degrees, I meant like negative 40, 40 below. Two technicians are discussing the intake air temperature sensor. Technician A says the intake air temperature sensor is more important to the operation of the engine, higher authority, than the ECT sensor. Technician B says the PCM will add fuel if the IAT indicates the incoming air is cold. Who's right about that? That's actually B, but let me tell you this. Let me tell you what I found out. One size doesn't fit all on this. And this is a story that I tell every now and then, and I need to make sure that you guys get it, okay? And I've told this story before, and anybody that watches my YouTube videos has probably heard me tell this story before. But it's really important in light of what we're talking about here. And I despise this phone. I should have left it on my desk. All right, let me see who this is. Hello. Hello. Yeah. Hey, you got that part in? Okay. All right, I'll get Gene to come by there and snag it. Thanks, Sam. I've been talking to that man on the phone for nearly 40 years. Because he's with parts. He's been behind the same parts counter all that time. Okay, now then, I'm going to tell you this little thing right here. And I don't know if you remember this. Dodge truck comes in to the body shop when the weather's warm. Warm weather. Comes in the body shop. They got to do a bunch of body work on it. It's in there a pretty good while because they had to put the bed on it. They got to do a bunch of other kind of stuff to get dents out of it and, you know, whatever, like body shop people do. And so when I was over there and I was between semesters or something, I can't remember, and we were off here, but they weren't all. I just drove by the Ford dealership to see how they were doing. And I said, anything you guys need to help with? And they said, well, there's a Dodge truck back there behind the body shop they want us to look at because it was starting and running just fine when they brought it in here to do all the body work, and now the stupid thing won't start. It's just sitting there spinning and spinning, and you smell gas and nobody can get it to start. And I said, well, I'll be glad to go look at that. That'd be no problem. And it was, I can't remember what year model it was, 98 model or something, maybe 99. So I went out there, and it was a full-size Dodge pickup, a Dodge Ram. And so I plugged my, well, first thing I did is I spun it over and I smelled gas. And I pulled the spark plugs out. Now, my way of thinking was the body shop has been cranking this thing and moving it around and switching it off, and they've wet the spark plugs. Got me? That happens. Somebody at a used car lot moves the daggum car around. They start it up. When it's cold, it's running rich because it's going to run richer when it's cold. They switch it off while it's still cold. They crank it up again. The plugs never really got a chance to, you know, they've still got, it was running rich every time they started it because it was always cold. And eventually those plugs get to where they start misfiring, and then they get it where they won't. And I said, this might happen with this. I've seen this before. So the first thing I did before I did anything else was I popped a set of plugs in it. You know, it wasn't hard to do. This was V8. I screwed plugs in there. The other one was just soaking wet with gas. Went to start it. It wouldn't start. I'm smelling gas. Did I figure out what was wrong? No, I did not. I mean, not at this point. I did know there was too much gas going in there. So then I pulled the DRB, and I got an article I wrote up on this somewhere, you know, called, you know, I can't remember what the name of it was. It was about a Dodge truck. So I pulled it up and I looked at engine coolant and intake air temperature sensor were not in agreement. And engine coolant sensor, now it was cold out there. You know, it's kind of chilly out here today now. It was colder than this. The engine coolant temperature sensor was reading about 43 degrees, if I remember right. The intake air temperature sensor was reading 101. You got me? Something's wrong with that, isn't it?
Yeah.
I go out here and I look at the intake air temperature sensor. It's brand new. It's just a shiny, brand new sensor right on top of the engine. And I say, somebody's already replaced this, and I'm reading 101. Let me back out of here and go into my OBD2 room, and let me see what goes on there. Well, when you went into the OBD2 room, you were reading -40. Remember what I told you the other day that they do? This thing had substituted 101 for -40. All right. So I got my voltmeter, and I measured it. And I was getting the same reading, 4.6 volts is what you'll get if you unplug it. All right, I got 4.6 volts, and that's true on most of these cars. Okay, so I said, with it plugged in or with it unplugged, I'm still reading 4.6 volts. Okay, what do I do now? What's one possibility? What do I know if I have unplugged the sensor? This is the little sensor here where it's screwed into the intake and all that. All right, I've unplugged this. And I'm keeping back probe. I'm keeping my back probe in here. This one here is what? That's signal return, right? That's a ground coming from the engine controller. This one here is the wire. It reads the temperature of the intake air. See, because you got air going through here, and it's got a little caged resistor in here. So I unplug this. With my back probe here, I'm reading 4.6. Plugged in, I'm reading 4.6. What's one possibility based on what you've already learned here?
It's not grounded.
If that wire, yeah, good answer, good answer. I mean, but in this particular case, I said, well, let me see if it's grounded. So I took my meter and I checked it from here to here. And I got 4.6. What do I know now?
It's grounded.
It's grounded. So that means, and so then what I did do, I took my meter then and I set it on the appropriate scale, you know, which would have been to the 200,000 ohm scale. Let's take the connector completely out of the picture and hook it up, and I measure, you know, oil, you know. This sensor is junk. It's no good. Now, this is the way that this thing probably played out, and I don't know this, but it was a brand new sensor. They went in there in a parts store, and they said, I've got to check engine light, and this was on a warm day, right? And they said, okay, they plugged in the scan tool, got a code for the intake air temperature sensor, pulled one off the shelf out of a box that was bad, that they didn't know was bad, screwed it in, plugged it in, same code. Well, it's not causing a problem, so I'll just keep driving the truck. Must be something else wrong, maybe a PCM or a wire harness problem. Well, whenever it's warm outside, if it's 85 degrees and this is reading 101, that's not much of a difference, is it? But if this is reading 43 and that's reading 101 and it's using that for fuel calculations, it's going to be putting all kinds of fuel in there because it's going to think my intake air is warm, my engine coolant is really, really cold, so I need a lot of gas. You understand what was going on there? All right, now this is what I did. I took my little wire that I disconnected here, and this is fun. You can buy those little potentiometers, and I've got one laying around here somewhere, that have like a 0 to 50,000. You know, why did I do that? 0 to 50K. And you can actually hook it right here. You know, your little potentiometer with your knob on it has got 3 wires. You hook this just like that. You hear me? You watch your scan tool, and you turn that knob until engine coolant and IEC are reading the same thing. And then you turn the key and it goes, whoom, it fires up. Because now we're getting the appropriate amount of fuel because we're telling it what the intake air temperature really is. And we know, see, I was going the extra mile. When I measured this and it was open, technically I was done. But I said, let's just see if it'll start with, you know, if I put a signal in there that's the right one. And that's, you know, confusing the computer into thinking that everything's okay when that sensor is actually at fault. Now, did you glean anything from that story? Did you get bored and all that kind of stuff?
I don't believe everything
Yeah.
that you see.
All right then. Well, basically, that was a logical way of checking it. You know, to start with, we actually stepped our way down to what the problem actually was, and my acid test was, does the truck start when I tell it the truth, and it did. All right, so let's see. When checking the ECT sensor with a scan tool, what about what temperature should be displayed if it's removed? It's 40 below. Two technicians are discussing the IAT, and that's number 7. That's B. I already talked about that one. A typical IAT or ECT sensor reads about 3,000 ohms when tested using a DEMM. This resistance represents a temperature of about what? 70 degrees. Because you're here in the, usually in a 70-degree temperature. If the transmission fluid temperature sensor indicates cold automatic transmission fluid temperature, what would the PCM do to the shifts? It would delay the shift points and the torque converter clutch would be disabled. Now the torque converter clutch is disabled whenever the transmission fluid temperature is cold, because if the torque converter clutch is locked in, you're not actually warming the transmission fluid up, because the torque converter is what heats up the fluid. So basically you want to disable the torque converter clutch so that that torque converter will be shearing the fluid and it'll warm that fluid up, because we like nice hot transmission fluid. Typical throttle position sensor voltage at idle. Oh, let me say one more thing, and I mentioned this before. Plug in your scan tool, pull up your temperature sensors, transmission fluid temperature, intake air temperature, and engine coolant temperature, and see if they all match if the vehicle has been sitting there a while. If one of them is way off the reservation, you'll know that sensor has probably got an issue. Typical TP sensor voltage at idle is about what? Now this right here, this is a GM deal. Half a volt is typically what GM has always used for idle. Ford usually uses 0.8 to 1 volt, 0.8 of a volt to 1 volt. But on this one, you're going to put B down there. Number 11, a throttle position sensor is what kind of sensor?
Rheostat?
Well, it kind of, you're thinking in the right direction, but a rheostat actually is something you use to control lights, and a throttle position sensor is just putting out a signal. So let's call it a potentiometer. And this is how this works, right? Let's just do this way. 5 volts, sig, return, which is reference ground. Inside the sensor, you've basically got this thing right here. And it's hooked there. And this slides up and down. The closer it slides to 5 volts, the higher the voltage on the signal gets, the lower it goes toward signal return, the lower the voltage gets. That's easy, isn't it? Is that complicated? All right. Are you dozing? All right. Now let's see. Let me see. Which wire, wait a minute, which of these does the TP sensor back up if the PCM determines a failure has occurred? Either B or C.
Okay, you didn't do 12 or 13. If you did, I definitely missed it.
Wait a minute, did I do this? Let's see, excuse me. Oh, 12. Well, I was actually just doing 13. Most TP sensors use how many wires? 3. Some of them use more. More about that later. Which of these sensors does the TP sensor back up if the PCM determines a failure has occurred? In other words, if it knows a failure has occurred on the mass airflow or the MAP sensor, MAP stands for manifold absolute pressure, and it's measuring engine vacuum. Low vacuum is high load, basically, and that's a speed density system. But that only works if it's not an in-range failure. Now, you remember this 88 Ford pickup we had that gray one that sat over there for so long that we worked on for all different kinds of things with a camper shell on it last semester?
Oh, yeah.
All right. That darn thing was just running horrible. Kind of like the one, that Taurus that we had out here. And what I did is I went out there and I set my little brown meter that I've got on Hertz. And then I went and I checked the signal going back to the engine controller, and I read like 140 Hertz or something like that. That meant that the MAP sensor was telling that it was at high altitude. It wasn't using the TP sensor in that case because it was an in-range failure, and the computer had no other input to compare it to. If all it can see is the barometric pressure that's being provided by the MAP sensor, which it looks at that on startup, and then starts measuring that as engine load after that, then if it's an in-range failure on the mass airflow, which is what we had, on the mass airflow on that Taurus. It was a terrible running car, and the TP sensor wasn't able to take up the slack until we did what? Unplugged the mass airflow sensor, and then what happened? When you unplug the mass airflow sensor, now it knows. And what a lot of people don't know is on some of these vehicles, the mass airflow sensor can cause a dead-gum no start. If it's internally shorted the right way, you got nothing, right? All right. Now let's look here. Which wire on a typical TP sensor should be back probed to check the voltage signal to the PCM? Look up here, y'all. What do you see? Which one would you back probe if you were going to check the signal going to the PCM?
Signal wire?
That's what I'm pointing to. The signal wire. That's right. The signal wire is the one that changes. These two are constant, or they're supposed to be. All right. Let's see here. Let's see. After a TP sensor has been tested using the min-max function on a digital multimeter, a reading of 0 volts is displayed. What does this reading indicate? The TP sensor is open at one point during the test. You know what the min-max function is, right? Let's talk about min-max. Some of you may have already seen it on some of our stuff. You're going to have the constant voltage here, right? And then down here, you're going to have 3 fields. You're going to have min, I call it current, and max. It's going to remember the lowest voltage it has seen, and it's going to remember the highest voltage it has seen. It's also going to be recording the voltage it's seeing right now. And if it's fast enough, and most voltmeters aren't as fast as an oscilloscope by any stretch of the imagination, if it drops out for a second, you're going to see that minimum volt read 0. And this one here, if it goes the other way for a second because the ground is broken, you're going to see it read 100%. And if you didn't go to 100%, you're going to know there's an issue. If you looked at it on a scope or a graph, what you would see is, like if you were going into your throttle and coming back, you would see it do this, and all of a sudden it would do that, or it would do this, when it should have been going smooth. You hear me? Now what happens to the way the engine is being driven? It's going to go and that's one of the things that you can find with your min, current, max, or your scope. All right. So number 15 is A, the TP sensor is open. If the TP sensor has been tested using the min-max function on a DBM, a reading of 5 volts is displayed. What you got there? Both B and C are possible. It could be shorted, or it could be shorted to the 5-volt reference. A technician attaches one lead of a digital voltmeter to ground the terminal of the TP sensor and the other meter to the negative terminal of the battery. In other words, you're going from signal return, which is your ground, to the negative terminal on your battery. Why would you do that? That's basically a voltage drop test of the signal return system. And that's number 17, that's D. And see, basically, look at the meter displays 37.3 millivolts. This is a signal voltage, blah, blah, so on and so forth. But basically, what you're looking at there, 37.3 millivolts is not enough to worry about, but you're doing a voltage drop test of that circuit. A PO122 DTC is received using a scan tool, and that basically means all of the above. Voltage is low, could be shorted to ground, signal circuit. The wire, the sensor, or whatever, the voltage is low because of a short to ground or a sensor is bad. The TP sensor affects the operation of all of these except correcting for rich and lean air fuel mixtures. Anybody got any questions?
Yeah, or 10 through 13.